Welcome to the second video in our Wordle series. In the first video, we created the scoring function, and we did that with test-driven development. Now, in part 2, we're going to create the guess validation function. Before we can score a guess, we need to validate that it is an acceptable guess, and there are a few requirements that we need to meet here. First, we want to validate that the word is in our dictionary. This not only validates that the word is an actual word, but it also validates that the guess is of the correct length, because we'll limit our dictionary to words of whatever length we want to play with. Secondly, we want to validate that this guess hasn't been already used in this game. We shouldn't let the user guess the same word multiple times. That doesn't really give them any new information. And thirdly, if we're playing in hard mode, we need to make sure that the user uses whatever information they discovered from previous guesses in subsequent guesses. So for example, if you got a correct letter in guess 1, you need to put that same letter in the same spot in guess 2. Or if you got an almost letter in one guess, you need to make sure that you use that letter somewhere in the word on your second guess. So we're going to write a validation function that checks for these three things. And because we have the requirements already set out, it's very easy to do this with test-driven development. So let's start. You might think that we would start with a test. However, we're actually going to start with a type today. And here's why. If you think about those requirements that we just listed, you can see that the validity for a guess is very much dependent on the current state of the game. That is, from game to game, you could see how the dictionary could be different, you could see how the previous guess history could be different, and you could see how hard mode could be enabled or disabled. And so really what we need is a way to keep track of all of that state, and we're going to create a game type to do that for us. So our project is right where we left off in the previous video, right underneath our letter score and guess score types. Let's create a new type that we're going to call game. So I think there are a couple of obvious things here. First of all, we're going to need to know what the answer is, and that will be a string. We've talked about hard mode. Let's create a Boolean for hard mode. We know we need to keep track of guesses. That makes sense as an array of strings. And then we also know that we have scores, and our score, as we know, is a guess score. So let's create an array of guess scores. The nice thing I think about this format is that we can know that whatever the guess at a particular index is, the score at that same index will be the score for that guess. Now, we should also keep track of the number of guesses remaining. In the official game, you can make 6 guesses, and we can probably stick with that here. So let's have a guesses remaining value. That will just be a number. We should also have the dictionary here, which will also just be an array of strings. You might not like the idea of putting the dictionary inside the game. To be honest, I could see the design here going either way. The reason I'm putting it inside the game is because I expect this to be running in a browser. I expect there to really only be one game happening at a time. Putting the dictionary inside the game type allows you to have a single object, a game, that you can pass around, and that has the entire state of your world. We said earlier that the length of the word is determined by the words in the dictionary, which is true, but I think we also want to have a max word length on the game as a number. And I'm just thinking ahead to when we build a UI for this and the data that we'll need to know whether or not we can actually submit a guess when we hit enter. Now that we have a game type, it seems to make sense that we also have a function that would create a new game object for us. Now, even though we're doing test-driven development, I'm not going to write tests for this because it should be a pretty simple function that just returns an object. There's no real business logic going on here, so it will be obvious if we break it and we'll know where to fix that. So let's go ahead and export a new function here, and we'll just call this create game. It's going to need to take a couple of arguments. I think one of those things will be the dictionary, and that will just be a string array. The other thing, of course, will be the correct answer for this game. And finally, we need to know whether or not hard mode is disabled. So we'll have a hard mode argument here, and we'll just default that to false. So what do we want to return here? I'm going to copy our type from above. So the answer is going to be provided for us. Hard mode will also be provided. Guesses will just be an empty array to begin with, as will scores. For guesses remaining, let's just go with 6. That's the default in the official Wordle, so we'll do that. The dictionary will be provided as well, and max word length, let's go with 4 for our use case. So there we go. We have a way to create a new game, and I think with that in place, we're ready to start thinking about the validation function that we started out to create. And that means we're ready to write a first test. So let's come over to our test file, and let's add a new describe block here. And this is going to be for a function called validate guess. Now this time I think it will be good to use a for each block here to create and set up our game instance that we can work on in each one of these tests. So let's create a new game here, and we can say Wordle.game is the type, and then in a before each, what we can do is instantiate a new version of that game. Let's create a dictionary and an answer, and we'll just say false for hard mode for the moment. Const dictionary, and we can choose a couple of words here. I'm just going to paste in a couple of items here that they're not really words, but they'll work for our test, and they'll give us some patterns that we can compare against. And then we can create our answer here, and we'll just use the last item in this list, AAAB, as our answer. Now that we have our test fixtures set up, we can write our first test. And I think the first one will be pretty simple. It validates that the word is in the dictionary. Expect Wordle.validate guess, and we'll pass it a word that is in the dictionary. So we have AAAA, and then we'll pass it our game, and we expect that to equal true. You'll remember we don't have a validate guess function yet. That's okay. That's how test-driven development works here. And we also kind of went through that quickly, but we chose a function signature here. I think it makes sense for the guess to be first and then the context for that to be second. So we'll pass the whole game right along. And yeah, let's pop open a terminal here and let's see this run. So we'll run yarn test, and let's see what we get. And we can see the error we expected, Wordle.validate guess is not a function. All right, so let's come over here to our business logic and let's create our new function. So we're gonna call it validate guess. We know it's gonna take a guess, which is a string, and a game, which is our game object. And for now, we'll leave that as an empty function. And when we save, we're going to get a new test, which says undefined, but expected true. So it got undefined. You know the rules, test-driven development. Step 1 is just get the test passing. So for this one test, the only thing we can do to get it passing is write return true. All right, so now, as you can see, our validate guess test is passing. Cool. The next test we want to write is we want to make sure that we return false if the word is not in the dictionary. So let's copy this test and paste it down here. And I'm going to change the name of this to be it rejects words that are not in the dictionary. Now that I come up with that name, I think I want to rename the first one here. Instead of saying validates, let's say that it accepts words that are in the dictionary. And let's change this to, I think if we have 4 C's, that's not in the dictionary, and so now let's say that should return false. And our test is failing. So let's work on the business logic here. At this point, I think it's obvious that the check for whether the word is in the dictionary is just an array.includes. So that should be the simplest thing to do. So let's say if, and we have game.dictionary.includes the guess, then actually if the game does not include the guess, then we should return false, and otherwise we return true. That's our first requirement. So it accepts words that are in the dictionary and rejects words that are not in the dictionary. Cool. This is moving along swimmingly. So let's write a third test. Even though a word is in the dictionary, we should reject it if it was a previous guess. So let's copy our first one here. Again, rejects words that have already been guessed. Now we have to modify our game so that it has that guess in it already. So we can do game.guesses.push, and we could push AAAA into the guesses. Now at this point, we would expect the state here to also have an item in game.scores. However, our validate guess function may not actually require that. You're probably already thinking, as I am, about how we're going to get this test to pass, and it will be pretty similar to what we did with the dictionary. We'll just check to see whether the game.guesses array includes this guess. So I don't think we're going to need that score. For now, I'm just going to push an item into the guesses array. At some point later, we are going to likely have a make guess function that will modify the guesses array and record the score for us. And so maybe at that point, we'll come back and change some of these tests. All right, so we push that guess into the guesses array, so it's already been guessed. And then when we validate that guess, we expect it to equal false, because even though it's in the dictionary, it's also in the guesses array. Of course, this test is failing. So I think this is going to be easiest if we go ahead and just write the correct logic. So we're going to say game.guesses.includes guess. And if that is the case, we'll return false. Now our validate guess tests are once again passing. Now it's time to think about hard mode. So when it comes to hard mode, there are 2 types of letters that we need to think about: correct letters and almost letters. So let's write a test for correct letters first. So I'm going to copy our latest test here, And the name for this test will be, it rejects words that do not use known correct letters. Well, let's take a look at what our answer here is. So our answer is AAAB. So if we make our first guess AABB, then we will have 3 correct letters. If we make our second guess BBAA, we will not be using those same correct letters that we had from the first word, so this is a good test case. We can set our guess here to AABB, and let's set our guess here to BBAA. Now we know that we're going to need a score to compare to, and when we just push into the guesses array here, our game doesn't get a score. So let's go ahead and set in the scores array here. We can't just push in the guess, we have to pass in Wordle.scoreGuess. Okay, there we go, and we expect validate guess to equal false. Cool, so let's save this, and if we take a look at the test, we can see, yep, it's failing as you would expect. Well, to get this test passing, I guess we need to walk through our guess position by position, and if at any position the previous word scored a correct in that position, then we should check to see that the letter at that position in our current guess matches the letter at that position in our previous guess. That's straightforward enough, so let's go ahead and find our last guess, and we can do game.guesses at game.guesses.length -1, and we'll do the same thing here for score to get the last score. And now let's go ahead and loop through our current guess. So as we walk through the guess, we want to check to see if last score at I is a correct letter. And if this is true, then we want to return false if the 2 guesses do not have the same letter at that position. So we'll check that last guess at I does not equal our current guess at I. And if that's the case, then we're going to return false. So let's just think about this logic for a second. The previous word scored correct at this point, but the current guess uses a different letter. Okay, so it's not correct. All right, we still have a test failing, but interestingly, it's not the last test. We've actually broken one of our previous tests, and I think you probably already know why. If we take a look at our test, we can see that in the first test, we don't have any guesses in the guesses array. We're validating the first guess of the game here. And so last guess is going to be undefined. There's nothing in this array. Same with last score. So when we try and index into those in here, that's going to throw an error. Actually, if we look specifically at what this error is, we can see can't read property 0 of undefined. Well, that's straightforward enough to fix. What we could do is just wrap all of this in a if statement. So we can say game.guesses.length. And if there's anything in there, then we'll know that we can actually perform a comparison. And if we save that, you can see that now all of our tests are passing. Excellent. So we're doing the right thing in hard mode when we have correct letters. Now, there's something that you probably have already noticed, and that is we haven't actually said that the game uses hard mode yet. If we look at our fixture here, game, we know that we set hard mode to false. Now, I've specifically ignored this so far because we don't have a test that says that this behavior shouldn't happen in easy mode or when hard mode is false. And so we're going to have to add a test for that. So let's go ahead and do that next. I'm going to do that above here. And we're going to say it accepts words that do not use known correct letters in easy mode. And I'm going to modify the test below to say it rejects words that do not use known correct letters in hard mode. Let's see. What we can do here is let's copy pretty much the exact same code here, put it up here. The only thing that really should be different between these two is something we need to make in our hard mode test, where we should set game.hardmode equal to true. Okay, so currently both these tests pass. However, that's because I didn't change this to true. All right, so now if we make sure validating guess should be true, and we can see that we're getting false. So to get both of these tests passing correctly, what we need to do is add a check for that hard mode Boolean. All of the hard mode stuff is happening inside this if statement. So let's just say if the game has guesses and game.hardmode is true, then go ahead and do this comparison. There we go. So we're accepting words that do not use known correct letters in easy mode and rejecting those same words in hard mode. There's one more requirement that we need to think about here, and that is, what about hard mode and almost letters? So let's go ahead and copy this same test, and we'll say it rejects words that do not use known almost letters in hard mode. All right, so now let's come up with some guesses that match this pattern. So we know that AAAB is our answer. If we use the guess BBBA, then we're going to have two almost letters, an A and a B. And then if we use the guess AAAA, we will not be using our almost B, and so that will trigger the scenario that we're looking for. Okay, so let's change our guess here to BBBA, and let's make sure we score BBBA as well. And then finally, let's make our guess AAAA, and that should be false. Cool. So if we save that, we can see that this test is failing right now. We already have a lot of stuff that we can use here. We know our last guess, we know our last score, we have a pattern for comparing them. I think we just need to do a similar comparison for almost letters. And we'll say if the last score is almost, then we don't want to compare the exact position of these letters, but let's say last guess dot includes this letter at this guess position. And we need to negate that. So if last guess does not include it, then go ahead and return false. So let's save that. And looks like we may have got that wrong. Let's see how this is failing. Now, this is an interesting scenario, and the honest truth here, this is not part of my script. I'm not sure why it's failing. There might be an obvious typo that I'm missing, but let's see what we can do. So first thing I want to do is validate that the test is what I expect it to be. So we're pushing BBBA and the score for BBBA in, and we have hard mode correct, and we're trying to guess AAAA. So let me confirm our answer here, AAAB. We guessed BBBA, right? So the B in our guess should have been an almost. And so because of that almost, we need to make sure that a B, yes, okay, I see where we went wrong here. We need to make sure that the B is in our guess and not that we've done this backwards. Okay, so let's come back over here. We don't want to check that our last guess includes the letter at this point. If the letter in the previous guess was almost, we need to make sure that letter is in our new guess. So we need to reverse this. We need to check that guess includes last guess at index I. That's what we need to do. So does our current guess include the letter that we used at this position last time? Okay, there we go. So if we save that, hey, there we go. Our tests are now passing. Cool. Honest little mistake there. Okay, very cool. So I think that pretty much does it for our validate guess function. We're checking that words are in the dictionary. We can't guess words that we've already guessed. We've got our hard mode and easy mode behavior defined. I think the one thing that I might want to add now is a function for actually making guesses. We've been doing this manually, you might say, in our tests, but I think it would be good to have an actual function for that. I'm not going to write tests for this. And this, I think, is an important point about TDD, because we did say in the previous video that when you're doing TDD, the idea is that you write a test for all production code before you write the production code. And that's the truth in principle. However, in practice, I'm often a little more practical about this, a little more realistic. Because the truth is, testing is a trade-off. Sometimes the complexity of the tests or the simplicity of the business logic make it not the right choice. In this case, I know that there's going to be very little actual business logic in the function for making a guess. And I know this because I can see what I'm doing to kind of mock the function inside of these tests. I'm really just pushing values into an array. And so I'm okay with not writing a test for this. Let's export a new function here, and we're going to call it make guess. Now, make guess obviously will need to take a guess as a string, and I think it should also take a game. Now, we could modify this game object, but I'm more interested in returning a brand new game object. My preference when working with data structures like this in memory is don't mutate it, but instead create a new one. So we're going to return a new game here. For the most part, we're just using the properties from the existing game. However, there are a few things we want to change. So guesses should be the existing game.guesses, and let's create a new array where we can cat the new guess into that array. We'll do the same thing with scores. So we'll say game.scores.concat, and we can call score guess. That might be enough. Let's see, what else do we have in our game type here? Answers in hard mode are not going to change. Dictionary max word length won't change, but guesses remaining should change. And we can set guesses remaining equal to game.guesses remaining -1. Now, we could actually make this a little more complex. It's not just -1. Let's say if game.guesses remaining equals 0, well, then it should remain at 0. Otherwise, -1. Actually, I think there's another case here, and that is, what if this guess is correct? We haven't scored the guess yet, but we can preemptively check to see if it's a fully correct guess by checking to see if guess is equal to game.answer. And if that's the same, then we'll also set it to 0. Now, there is a little bit of business logic in how we calculate the guesses remaining, but I'm okay with not writing a test for this, as I said before, because that data will be important for driving our UI. We're actually not using it anywhere in our tests or validation or scoring logic. Really, the guesses remaining is just for the UI, and if the UI is broken, that will be obvious to us, and so I'm okay not writing a test for that. The main takeaway from this is that really only you know what needs to be tested. Depending on the size of your project, the size of your team, the importance of this particular piece of business logic, the complexity of the tests that you might need to write, the stability of the feature, so many other variables, you need to decide, is testing the right choice here? There are two things that are definitely true. The first one is that most of the time, writing a test is the right decision. The second one is that every decision in software development is a trade-off. So make sure you keep that in mind as well. Okay, so we have our make guess function. Let's use it in our tests. Here, instead of doing game.guesses.push, we can say a new game will equal wordle.makeGuess, and we're going to pass in that guess as well as our old game object. We can replace both of these lines here with something similar. So we'll say game.wordle.makeGuess, AABB was our guess here. Now, this doesn't replace our hard mode line, but I'm going to copy the same line, place it down here. Let's do that one more time here. And this time the guess that we need is BBBA. All right, so if we save that, excellent. All of our tests are still passing. Well, with that, the business logic for our Wordle game is complete. And that means our test-driven development is complete for now as well. In the next video, we're going to look at integrating our game engine, if you can call it that here, with React. And there's some interesting techniques there. So be sure to subscribe so you don't miss it. And thanks for watching.